Assalamu alaikum. So can you see my screen as well?
Yes, sir.
Okay. So we have our mid-semester exam starting from 10th of January. So before that, I would like to make everyone sure about the syllabus for the exam. So we will follow this book, chapter number 1, 2, and 4. So if we go back in the context, in the contents, then we have covered chapter number 1, and then we covered chapter number 2 until 2.3, and then this part of the chapter is not yet covered, so I will cover it in the upcoming classes. But for today, I would like to start with chapter number 4. I am skipping for the time being chapter number 3 because it takes a little bit of time to understand about the uh, I mean about the derivations here. It's a bit difficult to get it in a very short time, so I keep it to study it after the mid exam. So then we'll start chapter number 4 about the breakers, circuit breakers, and that will be the end of I mean that will be the end of the uh, subject before the mid semester exam. And today we'll try to understand up to chapter 4.5. So we will need 2 more classes to cover chapter 4.6 and 4.7 in one class, and then in the last class 2.4. So I am sorry that at the end, in the last week, I have to take several classes, but I will help you to, go through the topics and, I mean, where you need to emphasize for the exam. I will also tell you what particularly you need to uh, go through in these 3 chapters. Okay, so I will be stick to the book, so that's the main thing. So if you go through the book, I hope it will be easy for you for the exam. Okay.
Sir, have you shared the book? I'm sorry to ask.
Yes, I have shared the book in classroom. So this is the classroom, you can see, and in the
Okay.
classroom you will find the book here. So in the first
O-
post is the
Okay.
textbook. Can you see my screen?
Yes, sir. Yes, sir.
Yes, so here is the PDF. You can download the book from here, but there
Okay,
will
sir.
be another reference book. I will share it today. It's only for
Okay.
clarification if you need to clarify more on the subjects, but I
Okay.
recommend to go through this book first. It's not too much. I mean, the chapters is not a lot. It's not
Okay.
that difficult. Okay,
Okay.
so yeah.
Okay, sir.
By the way, do you know when is your exam?
We have not set the date yet, but when we do, we will let you know, sir.
Okay. Okay, so we can start with chapter number 4 today. So if you have any trouble understanding, please let me know. Okay.
Okay, sir.
Okay. So chapter number 4 is about the circuit breakers. So do you know about circuit breakers? Can anyone tell me what it is actually?
Sir, it is a protective element.
Uh, for what?
Sir, for power system applications, sir. Sir, for our line.
Yes. And what does it do actually?
Sir, it stops the flow of current in under voltage and over voltage problems, sir.
Okay. So it's not 100% correct answer. Okay, so in a power system, so what happens is that, so in a power system we have bus bars, right? So in the substation we have bus bars, and from these bus bars there are line coming out, we call it feeder. And in the feeder we have different loads, for example the consumers, the household or industrial loads, they are connected. And these bus bars are, I mean, probably they are connected with another substation. Of course there will be transformers here if it needs to be stepped up or stepped down, or I mean it is also connected with generating stations. So this part of the grid is like interconnected and it's a meshed grid configuration. So you have many cross interconnection between one station to the another station. Okay, and here in the distribution part, it is rather is called a radial connection because it's coming out radially from the bus bar, and it's like a line that is coming out radially. So it's called a radial connection. And in the power system, if any fault happens, okay, so if you have any fault, let's say if there is a fault happening here, so a fault can be an earth fault. That means one of the conductor, it may touch the ground. I mean, it may get short circuited. Two of the conductors may get short circuited, or three of the conductors may touch each other. So in those cases, basically the current will flow to the least impedance path, and it will bypass the load. So the current will not go to the load. It will not go to the load because load is having a high impedance. Instead, it will see that this path is much easy to flow for the current to flow. So the current will flow to the least impedance path, that means through the fault. So the fault current will be very high. So the current that will flow through the line will be very high, which is of course damaging for the power system. So this fault needs to be cleared. It needs to be cleared away from the power system, because it's like a faulty part of the system. And you know that the uh, faulty parts needs to be uh, taken out from the healthy part of the system. So circuit breakers are placed here, and its job is basically to take out or interrupt this high short circuit current. So circuit breaker is a device which can basically turn off high amount of current. Now in your household, when you try to switch on and off your fan or light, often you see that when you turn off the switch, you will see that there is a spark in the switch. Now this spark is of course not very big in a in your household, but in a substation, when the amount of power flowing to the substation is very high, then if you try to interrupt the current, you will see that there is an arc that you cannot basically extinguish without the help of circuit breaker. So if you do not have a circuit breaker, you cannot interrupt the current. Am I clear?
Yes, sir.
Okay, so we can see a very short demonstration about the arc, basically what it is. So okay, okay. So for instance, So can you see it?
Yes, sir.
So this is inside a substation. So inside a substation, you have isolators. So these isolators are used to isolate the line. And here you can see that when the isolators are being opened, then you basically create a very long, very long arc, which is carrying the current. So arc is something like this. And you cannot basically interrupt this arc if you do not use the circuit breakers. So circuit breakers are a specialized device that are basically designed to shut down this arc, to interrupt this arc, and to clear the fault. Am I clear? So this is the case. You
Yes,
can
sir.
see the arc is burning and without interrupting, because these isolators are not meant to interrupt the arc. Okay. On the other hand, you have the uh, high voltage circuit breakers in the line that from the outside it looks like this. Okay. From the outside in the substation, you have equipment like this. So you also have an arc burning inside this circuit breaker, and this device is designed to interrupt the current or stop the flow of the current. Now this stopping of the flow of the current can take place because of if you have a fault. So in the faulty condition, you have a very high amount of fault current will flow. That means the IF, the fault current, will be very high. In some cases, you may want to switch the load current. Okay. So for instance, if you have a load connected with the substation here, a load that is being connected, and let's say if you want to do a load shedding, so you may need to turn off the load. So in the load current case, uh, the value of the load current IL is normally less than IF. So the circuit breakers are also designed to turn off this load current. Now, if I draw the schematics of this system in a very simple way, then it will look like this. So we have a voltage source, which is basically this part here. And then you have the inductor. This is the stray inductor in the line. And then you have the switch. And then let's say you have a load. Load is given by L. No, here this is given by source inductance LS, and this is load. Okay, and then is the return path. So in the normal operation, when the current is flowing through the load, at that time the load current IL would be basically depends on the source voltage Vs divided by the impedance in the stray inductor here Ls and load. So IL will be Vs divided by uh, reactance from the Ls plus load. But if you have a short circuit here, that means the load is being bypassed. So IL will be basically Vs divided by reactance from this Ls. So you can clearly see that the short circuit current, that means the fault current IF, is much higher than IL. Am I clear?
Yes, sir.
Yes. So the circuit breaker needs to interrupt both of these current. Okay. And in the circuit breaker, when it inside the circuit breaker, you have basically contacts. That means a contact which is in on condition. During the on condition, the contact on the left hand side and the contact on the right hand side, they basically touch each other. So if I show you here, so So it looks like this. So you have the contact 1 and contact 2. So when they are when the circuit breakers is on, that means when this switch is on here, when this switch, when this is on, that means it is carrying the current. Okay, the current is flowing through it. When it is off, that means it's off, and at that time you are not having any current flow. So when this switch is on, at that time you have both of these contact is touching with each other, but in a microscopic scale these contacts have surface irregularities, and because of these surface irregularities, it is actually not all the surface of the contact is touching with contact 1 and contact 2. Rather, there are few points where this contacts is touching and the current is actually flowing through these few points. And when the circuit breaker is actually opening, when it opens, then gradually you have the contact is touching at the at a, I mean, in this first case you have at a 5 points the contact is touching, and then when these two contacts are separating, then there comes a point when the current is flowing only through a single point. And as all the current is flowing through a single point, so this single point will be overheated, because you know uh, the the current density here increases. So we know that from the Ohm's law, we know that our current density J is equals to sigma E. So your as the current density is very high, so you have more losses here. As the current density increases, so you have more losses here, or the resistance here increases, right? So as a result, this part where this part of the contact where it is only connected in a single point, it gets melted because of this high amount of current flow. In other words, you can think like that, that if if you have a solid conductor of a very high thickness, the current can flow very easily. But if the same amount of current tries to flow with a very narrow conductor, then this narrow conductor, as it has much higher resistance, because resistance is R is equals to rho L by A, where A is the cross-section area. As the cross-section area is very, very small, the effective cross-section area, so the resistance value increases. Or in other words, you have much higher amount of losses coming out here because of I square R loss, which basically increases the temperature here, and gradually it melts. And as the contacts uh, opens even furthermore, then you basically, as the temperature here increases further, the gases surrounding the contact, if it is burning in air, so you have basically oxygen and nitrogen gas. So these gases very close to this molted contact will the outermost electrons from the shell will basically leave, and then these gases will become ionized. So nitrogen will become nitrogen molecule will become nitrogen atom first, and then if you even increase the temperature because of this high temperature originating from a single point, this nitrogen will leave its outermost electron and it will become N plus an electron. And if the temperature is even further increased, so it will lose two of its electrons, so it will be 2 plus, or it can be written plus 2, and then you have one more electron. So basically, as the temperature here increases, this nitrogen from a insulating state, we know that nitrogen and oxygen, these are uh, I mean in ambient temperature, at room temperature, these are pretty good insulating gases. But as the uh, temperature increases to a very high point, let's say around 5000 Kelvin, So at this point, your nitrogen and oxygen gases, they dissociates and they become ionized, and this ionized gas can carry the current because this ionized gas has basically certain charges and they can move from one point to another. Now these electrons, if this part becomes positive and this part becomes negative, so if you have an electron here, so this electron will be attracted by the topmost electrode. And in AC circuit, you know that you have, in AC circuit, you know, basically you have the polarity is changing every time, right? Can you
Yes, sir.
get me what I'm trying to say?
Yes, sir.
Yes. So in half cycle, the top part will be positive and the bottom part will be negative. In the next cycle, the top part will be negative and it will be positive. So this electron will move from here to here. In the first half cycle, it will flow from bottom to the top. In the second cycle, it will flow from top to the bottom. That means the current will be carrying by these electrons and ions. So that is exactly what is happening in this switching arc. So in this arc, this is a very high temperature. That is why you can see it as you can see the light. So this light is only visible because this high temperature is actually the electrons when they come out from the outermost shell, and then when they recombine, they emit the light. So when they recombine and then they emit this light, and this is exactly the light you can see from the arc. And the current is actually within this arc, you have basically this ionized particle uh, from the you have basically the ionized particle from nitrogen and oxygen, and this is basically carrying the current. So the arc is a conducting channel, so it's carrying the current. Am I clear?
Yes, sir, you're clear.
Okay, and the circuit breaker's task is to stop this arc. Now, the mechanism to stop the flow of the arc is lies here within the temperature. So, if by anyhow, if you can reduce this temperature down, so if you can cool down the arc, so if you, for instance, if you have a something that is very hot, if you can take out the heat, then the temperature of that medium actually goes down. For instance, if you look at a very hot water, if you take down, if you cool down the water, the temperature of the water goes down. So something similar, if you can do it within the arc, so if you can cool down the arc and if you can take out the temperature, then these ionized particles will basically recombine. So instead of ion, they will become nitrogen molecules and oxygen molecules. So these molecules are uh, are insulator. So the circuit breaker's task is to cool down the arc so that the ionized arc can become insulating. Am I clear?
Yes, sir.
Yes,
Okay,
sir.
okay, very good. So you can go through this text. What I try to say, it's more or less written in the same way. Okay, so we record the following from a circuit breaker. So what the circuit breaker should do is basically in the closed position, it should be a good conductor. So during the closed position, so when this circuit breaker is on, um, that means um, here in this stage. So when it is on, at that time, it should be a perfect conductor. So the circuit breaker should have less, I mean, it should be properly connected between the two contacts. They should be properly connected, so the current should flow uh, very easily. If it does not, then you would have heating. So if it is only touching at few points, then all the currents would actually flow through these few points and the temperature between the contacts would increase. So this is not exactly what you want. in ideal case, you do not want any losses in this point. So if uh, the main task when it is in on position is to make sure that the contact resistance is very low. So that is one thing. And in open position, it behaves as a good isolator between the system parts. And when it is completely open, then it should be able to isolate the two part of the electrical networks. For instance, here, so if the circuit breaker, this is the switch. So when this is open, then it should make sure that it is fully open. So no leakage current or no current is actually flowing through this line. So it should be fully open. It changes in a very short period of time from close to open. So this transition from the close to open position should be very fast, and it does not cause over voltages during switching. So when it switches, it should not create any over voltages. So why these over voltages are important? Where this over voltage is coming from? So in the electrical network, as we try to model here, so this is I can redraw it again. So we have our system voltages here, and then we have the inductors. This inductor is coming from the transformer and transmission line, and then you have the circuit breaker, and then this circuit breaker is connected again to a load. Now this load can be it can be an inductive load, for instance. Right. So when you try to turn off, so in the normal condition, the circuit breaker was on, so the current was actually flowing from left to right. And when you try to turn it off, that time you are basically turning it off. And you have also stray capacitances here. Stray capacitances are capacitances that you cannot see in your open eyes, but they always exist because of the high voltage between here and here, and because of the insulating medium. So you have a stray capacitor here. So when you open this circuit breaker, basically some amount of charges, I mean, some amount of current will flow through this inductor, and it will force this inductor current to circulate through here on the right hand side. And in the left hand side, you have also a current flowing through here. So at this point, the voltage will be the source voltage here, and on the right hand side, this voltage will oscillate. And because of this oscillation, you have a transient voltage coming here. Now, the circuit breaker's task is also to not make over voltage during the switching. So an ideal circuit breaker would actually reduce this over voltage. Okay. And if the circuit breaker is not ideal, if it is not very good, then